Hi everyone, welcome to our 11.3 Day 1 video lesson on areas of regular polygons. Let's first refresh ourselves on what a regular polygon is. The definition is it's a polygon with all sides congruent and all angles congruent. So here are some examples of some regular polygons. So here's a regular hexagon, this turquoise blue color, where all sides are congruent and all angles are congruent. Same thing with all of these polygons up here. This pentagon, all sides are the same length, all angles are the exact same degree measure. Okay, so that is the definition of a regular polygon. And to find the area of a regular polygon, the area equals 1/2 times the perimeter times the apothem. So 1/2 PA. So now we have to define what the apothem is. So when we take a look at the pieces of a regular polygon, the center is the very middle of the polygon, the center of the polygon, and the apothem is the segment that goes from the center of the polygon perpendicular to a side. So as you can see, this blue line, now this green line, I guess, is the apothem. I could also draw the apothem right here. It's the exact same distance as long as it's perpendicular to a side. I could draw the apothem right here as long as it's perpendicular to the side. So like I said, the area of any regular polygon, you could take 1/2 times the perimeter, which is the distance around, multiplied by the apothem of the polygon. Okay, and that apothem is the distance from the center perpendicular to a side of the polygon. All right, let's find the perimeter of these. A regular octagon has a perimeter of 48, and the apothem is 7.2. Find the area. This is about as basic as we can get. I give you all of the information that you need. The area is 1/2 perimeter times apothem. Notice, class, how this is a capital A. That stands for area. The lowercase a stands for the apothem. So don't get those two A's mixed around. The capital A means area. Lowercase a means apothem. So what is the area? When 1/2 multiplied by the perimeter, it says the perimeter is 48. Multiplied by the apothem, it tells us the apothem is 7.2. So if we take 1/2 times 48 times 7.2, we get 172.8 centimeters squared. And there is the area of that regular octagon. Taking a look at this next one, find the area of this regular heptagon. Okay, so to find the area of a regular heptagon, it's 1/2 perimeter times apothem. Let's see what I know. I know what the apothem is. The apothem is 10.9. So area equals 1/2 times the perimeter times the apothem, and the apothem is 10.9. So now, class, what I need is I need to find the perimeter. I need to find the distance all the way around this heptagon. Well, I could start off hopefully by finding this right away. Did you guys see how we have a right triangle right here? So we can use the Pythagorean Theorem. I'm going to put an x right here because that's what I want to find right now. So we have x squared plus 10.9 squared equals 12.1 squared. I trust that you guys know how to find that using the Pythagorean Theorem, so I'm just going to tell you what x is. X is approximately 5.25. X is approximately 5.25. So that's how long this blue segment is right here. So if this is 5.25, what's the perimeter? This would also be 5.25. If this is a regular polygon, the apothem bisects the segment, so it's perpendicular and it bisects it. So 5.25 plus 5.25 is 10.5. So this is 10.5, this is 10.5, this is 10.5, this is 10.5. You get the point, right? All of these sides are 10.5. So the perimeter would be 10.5 times, a heptagon has 7 sides. So 10.5 multiplied by 7 is 73.5. There is my perimeter. So you had to use the Pythagorean Theorem to find this length. Once you get that length, you double it to find the whole side. and then you multiply that by 7 to get the perimeter of the whole polygon. All right, now we have everything we need, so we simply multiply it. 1/2 times 73.5 times 10.9. And that area is 400.6 inches squared. 400.6 inches squared. Let's never forget what area means. There are 400 of these square inches that fit inside this heptagon. 400.6. The area of a regular decagon is approximately 207.9 centimeters squared, and the apothem is 8 centimeters long. What is the perimeter of the decagon to the nearest tenth of a centimeter? All right, so the area of a regular decagon. I know that a regular polygon, the area equals 1/2 perimeter times apothem. And it tells me what the area is. So 207.9 is the area. Why don't we put that in right there? 207.9. That equals 1/2. What else does it tell us? It tells us the apothem is 8. So 8 goes there, and it wants us to find the perimeter. So 1/2 of the perimeter times the apothem is 8. All right, I'm going to solve for P now. So I'm going to kind of hop up here. Hopefully this isn't too confusing. But 207.9, that equals 1/2 of 8 is 4 times perimeter. Divide both sides by 4, and I get the perimeter. To the nearest tenth, the perimeter is 51.975. So I guess to the nearest tenth, it would be 52. 52 centimeters. So if the perimeter is 52 centimeters, it says, what is the length of each side of the decagon? Well, if all 10 of these sides, right, whatever, if all 10 of them totals 52, how much is each one? And if they're all congruent, we would just take the whole perimeter and divide it by the number of sides that there are. In our decagon, there are 10 sides. So 52 divided by 10 is 5.2 centimeters. That is the length of each side. All right, then our last one for the day. Find the area of a regular heptagon with side lengths of 9 centimeters. So each of these sides is 9. Okay, so with that, we could find the perimeter. That's easy enough. Area of a regular heptagon, or any regular polygon, is 1/2 perimeter times apothem. So our heptagon has a perimeter of 9 times 7, right? Because there's 7 sides and they all have 9. So 9 times 7 is 63. Perimeter is 63. All right, friends. What is the apothem? How long is it? The apothem is the distance from the center of the polygon perpendicular to one side. Right? So this is my apothem. That's what I want to find right now. All right, pay close attention. What I'm going to do right now, if this is 9, if all of these are 9, half of it would be 4.5. Okay? Now, this angle right here, that angle right there, there are 7 of these triangles in a heptagon. 8 in an octagon, 9 in a nonagon, right? You can divide this into 7 congruent triangles. And these angles are all going to be congruent. So if we take 360 and divide it by 7, 360 divided by 7, each of these angles is roughly 51.429 degrees. And now, if I take this triangle right here, this angle, one with 2 green arcs here, is half of the 51.429. So if I divide it by 2, this angle is 25.71 degrees. Now, class, I could use trig to find the length of my apothem A right here. Okay? So let me draw this a little bit cleaner so that you can see what we're solving for. This is my apothem. That's what I need to find. This is 4.5 right here. And my angle up here is 25.71. Now I can find my apothem by saying opposite and adjacent. That uses the tangent function. So the tangent of the angle, 25.71, that equals opposite, 4.5, divided by the tangent, which is my apothem. Or, sorry, divided by my adjacent side, which is the apothem. Now I can solve for A. I'm going to move this down here. My apothem I'm going to move up here. So A equals 4.5 divided by the tangent of 25.71. I put that in my calculator, and the apothem is roughly 9.344. The apothem is 9.344. And so if my area equals 1/2 perimeter times the apothem 9.344 goes right here, 9.344. And there is my area, 0.5 times 63 times 9.344. When you multiply those three numbers together, you get approximately 294.34 centimeters squared. And there's how you find the area of any regular polygon. We'll do some more work with this when you get to class tomorrow.